morning. In the last class, I discussed about the air conditioning and the psychrometric processes. Psychrometric class we have seen. So this class also, I will just go through in last class what we have discussed initially. I think you know what is the psychrometric chart and what are the psychrometric terms and how you can take the values from the psychrometric chart. Now today, psychrometric chart, identify the use of the psychrometric chart is identify the part of the chart, determination of moisture air properties, use chart to analyze processes involving the moisture air. So in the last class we have seen what is the moisture. So this already have seen psychrometric chart and it's involving some important terms also, and it is also called, we have seen shoe chart because it looks like a shoe. That's why it's called shoe chart also. Next. So in this psychrometric chart, if you divide each lines, one is the dry bulb temperature, where the lines are vertical lines, I have seen in the last class also, and this is the dry bulb temperature, this is centigrade. If you want to calculate some psychrometric some terms, you can use this dry bulb temperature, one of the input. Then the next one is the wet bulb temperature line. These are the inclined lines, and the wet bulb temperature, it is 85 degrees centigrade, and slowly it becomes reducing. Okay, so if you know the dry bulb temperature and wet bulb temperature, then also we can calculate the remaining terms also. Next slide. Then the relative humidity line. So these are the curved lines. The relative humidity is the moisture content in that. And if you know the relative humidity and the dry bulb temperature also, you can locate that point where these two are meet. With that reference point also we can take the remaining terms also. These relative humidity line, this is the 100% RH, and slowly it becomes the reducing the percentage. Then the horizontal lines, which are the humidity ratio. This is the humidity ratio or specific humidity in called the kg of moisture per kg of dry air. So this also we can calculate based on the some other values. Next. Then the dew point temperature line. These are horizontal lines where the dew point, it is on the saturation line. This is the saturation line, already we have discussed. So this dew point temperature we can locate with the help of the dry bulb temperature, relative humidity, or dry bulb temperature and wet bulb temperature. Next. Then the specific enthalpy line. It is also like a dry bulb temperature line. It is also inclined line, and this line is called the enthalpy line. It is in kilojoules per kg, specific enthalpy. So this value also we can take with the help of the dry bulb temperature, wet bulb temperature, or dry bulb temperature relative humidity. Next. Then the specific volume line. This is also inclined line. It is meter cube per kg, the specific volume. So this is also we can calculate with the reference point. So these lines is almost the wet bulb temperature also inclination line, but somewhat the plant is different, the specific volume line. Next. This is cyclometric chart. Example, already we have discussed in the last class also. If you know the T, that is the dry bulb temperature, 25 degrees centigrade, and the wet bulb temperature, 20 degrees centigrade, we can calculate the following, that is the relative dew point temperature, humidity ratio, and the specific volume, and the enthalpy also we can calculate with these 2 points. And in the last class also have seen some problems also. How to locate on the cyclometric chart, and analytically also we can do. This is the cyclometric chart, and we know the data, that is the dry bulb temperature is 25 degrees centigrade and the wet bulb temperature is 20 degrees centigrade, where these two coincides, somewhere this is the point, reference point. You locate the point on the cyclometric chart, and then you can take all the remaining values, and this is the reference point. Already have seen the previous graph. The horizontal lines is specific humidity or humidity ratio, and then the inclined lines, this is the humidity ratio, 12 grams per kg of dry air with this value, and then the relative humidity at that point. These are the curved lines where the relative humidity is 63%. And like that, this is the dew point temperature, 17.6. I think it is not visible clearly. This is the 17.6 degrees centigrade. If you have any cyclometric chart, also you can practice. You locate that dBT and WBT, and with that line you can take the values also, so that it very clearly understand. Then this wet bulb temperature line is also similar to the enthalpy line, same line. You extend this line up to the very saturated line, that is saturated line. You can get somewhere here, this value is, that is a specific enthalpy, which is the 57.5 kilojoules per kg of dry air. So this is the point, reference point. Then you can calculate the remaining. Suppose if you know the dry bulb temperature and the relative humidity, also you can note this point with the help of these two values also. Then you can calculate the remaining things also. So this is the advantage of this cyclometric chart. Next. And then the specific volume also is given. Please go back. Yeah, this is the specific volume. It is also not very visible. 0.86 per kg of dry air. So we have next previous question, and these are the already we have seen on the chart, the relative humidity or humidity ratio, then the dew point temperature calculated, and the relative humidity percentage, and this is the humidity ratio or specific humidity. This also have seen, and in the specific volume we have noted on that, and the specific enthalpy also. So with these two values, you can calculate all the remaining values, and if you know the relative humidity also without this wet bulb temperature, you can calculate all the relative humidity and dry bulb temperature, humidity ratio, specific volume, and enthalpy. Next. So this is the actually cyclometric processes. So this is the center point, and this side is the dew point temperature. This is the moisture content, that is the specific humidity, and the specific volume line. This is in meters per kg. Then this is the wet bulb temperature, degree centigrade, and if you extend this line parallelly, then it is the specific enthalpy line. You have seen the previous graph, and then the relative humidity also, this curved line is relative humidity. So like this, you can calculate the remaining all the values. Now, coming to the basic processes in air conditioning of air. conditioning of air. So in the graph, psychrometric chart, say, it is visible. This chart is visible for you. So suppose this is the point, reference point, and we have located some ABCD up to H value. First one is the sensible heating process, that is the OA. Where it is OA, always, if you take the psychrometric chart, this is the reliable temperature line. Right side, always it is heating. That's why this is called the sensible heating process. From say O to A is the sensible heating. Next slide, please go. This is same diagram. Then next one is sensible cooling. Automatically the opposite of the heating is cooling. So this is the sensible heating. Then this point is, if you come to the opposite side, then it is a sensible cooling. Okay. Then let me purify. Purifying means purifying. From this point to go upward, right? Next slide. Therefore, the drying rate may be WA 30 somewhere. Finally, the value, the drying rate is 13 kg per hour. Next. Then coming to the vent. Calculation rate of ventilation airflow. What is the importance of ventilation? Suppose if you are providing the air conditioning, already have talked about the infiltration, that is how much air is entering into the room. And the ventilation also, you have to, through windows or maybe any provision should be there. Next. Factors affecting flow due to the factors affecting because of the wind velocity, that is the average velocity, prevailing seasonal and daily variation of wind speed and direction, features, that is the local. Then how to calculate the airflow. We are talking about the how much air is coming inside, outside air, that is the airflow due to wind. Q is the EAV, where Q is the airflow in feet cube per minute, and A is the area of the inlet opening, then the wind effectiveness of opening. Next, these values are standard values. Next value. Then the types of natural ventilation opening. So how we can provide the ventilation? That is windows. There are many types of windows. Sliding windows vertically, sliding windows horizontally, tilting, swinging. The type of swinging type and vertical windows also. Then the doors, maybe already we are talking about the infiltration or air, how it is entering. Monitor openings and skylights. Monitoring openings means maybe if any system is working, it gives some lighting. Then the roof ventilators, weatherproof air outlets. This is also one type of ventilator. The stakes connecting to the register. Stakes means air entering. Suppose there is a small gap, door to the floor, that's called the stake. Then the specially designed inlet and outlet opening. Next slide. Then convertly, right? I am talking about convertly. So the separation from okay. So I am talking about the infiltration. Infiltration is air leakage through cracks and interstices around windows and doors and walls into the building. Already we are talking about the infiltration, how to calculate infiltration, how the air is entering into the room. That's why leakage rate, houses 0.2 to 1.5 air changes per hour in winter, infiltration through a wall. Therefore, the rate is, you can calculate C into delta P, where P is the volume flow rate of air and C is the flow coefficient. Then the delta P is the pressure difference, that is the outside pressure and inside pressure. And the N is the flow exponent, that is 0.5 to 1. Normally, the standard value is 0.65. Next. Infiltration, air moves at varying rates, depends upon the number of factors relating to both the structure and meteorological conditions. Two terms are infiltration and ventilation. We are talking about ventilation also. Both are measured as air exchange rate or air changes per hour. That is air changes per hour. The ASHRAE, ASHRAE, this is American Society of Heating and Refrigeration Air Conditioning Engineers, defines infiltration as uncontrolled airflow through cracks and interstices and other unintentional openings. So a man is coming, you want to open the door. That is the unintentional openings. So this cuts the air condition also. Next. Infiltration occurs because of the building, because no building is completely airtight. You can't provide these type of openings and air leakage also. Teacher and the teacher creates driving forces which push or draw the outdoor air through openings into the building. Infiltration is the rate of exchange of outdoor air with the entire volume of door air quantitated as the air change per hour. Next. Then the factors affecting the air, these are the factors affecting that is meteorologically, then heating and cooling systems, occupant activity. Already I am discussing the occupancy load is what type of occupancy load, whether it is a classroom, whether it is a physical exercise, that is gymnastic room, or maybe it is a sleeping room. The occupant, what is going on, or maybe you are simply doing your work. The structural parameters also, in the quality of construction, that means maybe the walls, maybe sometimes maybe it is constructed with the bricks, or maybe nowadays some fly ash bricks. And what is the thermal conductivity of the material? Maybe sometimes you can construct maybe with wood also. So what is the thermal conductivity of that wood? Also we have to consider. Suppose the outside temperature, maybe with that through media, that is wall, maybe it is a iron wall also sometimes, or maybe some partition, that is also affected. In the material of construction is the same. Condition of the structure also it influences. Then the meteorological airflow rate due to infiltration depends upon the pressure difference between the inside and outside of the structure and the resistance to flow through the building openings. These are the factors affecting the infiltration. Then the wind effect. Shell and exterior air barriers, interior barriers to flow that cause internal pressure buildup and thus reduce the infiltration. Lack of precise knowledge of the detailed wind pressure profiles on the building surfaces. Influence of complex terrain, presence of trees and other obstacles that creates channeling and may increase the magnitude of wind force and alter the direction close to the structure. That means that suppose if when outside, if the air is flowing, maybe the tree may be obstruct the air flow. That's the meaning. Next, sheltering urban canine and building wake phenomena due to surrounding building and other neighborhood factors also. That means that maybe some number of buildings are there, and due to that also maybe the air changes may be there. Fluctuating windows rather than linear wind forces that may be affect infiltration rates through the wind cracks. Wind crack means already discussed, maybe any crack in the door or maybe window. Next, then the temperature effects. The temperature inside a structure is often different from the out ambient air temperature. Maximum temperature differences occurs when the indoor environment is heated. Temperature differences cause differences in air density inside and outside, which in turn produce pressure differences. Next, these are all in the winter when indoor is temperature are high relative to the outdoor, because maybe the interseason the outside temperature is very low compared to inside, right? The warm and less dense air inside rises and flow out the building at its cap. This air is replaced by cold outdoor air, bottom of the building or from the ground. This phenomena is called the building stack effect. Already I am talking about stack. What is stack? This one. The air is replaced by cold outdoor air that enters near the bottom of the building. Somewhere. That is called stack effect. During hot weather, when air conditioning produces a lower temperature inside the outside, the reverse process occurs automatically. Okay. Next. Then the humidity effect. Stryker in 1975 reported that homes with low infiltration rates had high humidity. In a study by R&Ac 1987, in 24 apparent relationship was found between the relative humidity and air exchange rate. One of this lack of association is that absolute humidity rather than the relative humidity may be better measure of any effect the water content of the air has on infiltration. This is the humidity effect. Next slide. Another indirect method to estimate the air infiltration is it can be interrupted if infiltration occurs. The empirical model used to estimate air exchanges is based on the pressure differences. The method involves measuring the dimensions of each opening and converting this value to a leak area equivalent value. Maybe in your syllabus, just how to calculate the infiltration. That is enough. And what is the ventilation? How you can provide the ventilation? What is the ventilation effects also you can calculate. That is enough. Next. And how to calculation the ELA? This is the formula Q delta P by rho to the power of 0.5, where to air leakage meter square, the air flow rate Q, and then the delta P, the pressure difference, that is outside and inside pressure, the density of air. The standard is 1.2 kg per meter cube. Next. Then, according to your syllabus, the sensible heat factor is that already we are talking about the sensible heat and sensible cooling, right? Heating and cooling. It is the ratio of sensible heat transfer to the total heat transfer. mathematically the sensible heat factor is 2s by sensible heat factor is sensible heat plus sensible heat by the ratio of sensible heat plus latent heat, which is called the total heat. Here also 2s plus QL is Q, this is total heat. So this is how to calculate the sensible heat factor. Next slide. It is defined as the ratio of, that is the grass sensible heat factor, not grand, grand or grass, we can say. It is defined as the ratio of grass sensible heat, grass total heat in the effective sensible heat factor, that ESSF, which is effective room sensible heat by effective room total heat. With this formula we can calculate. This is a room sensible heat factor. It is the ratio of room sensible heat to the room total heat. Next. In the operator's dew point, the ADP, the effective surface temperature of the coil is known as operator's dew point. And that is also you have to find out if you want to calculate the problem. You can locate on the with the help of the values in psychrometric chart. You can calculate the ADP also. Next. Then the bypass factor. Under ideal conditions, the dry bulb temperature of the air leaving the operator should be equal to. It is not so because of the inefficiency of the coil. This phenomenon is called the bypass factor. We can calculate the bypass also when the mixed air, if it is flow. It means that maybe in the further classes we can discuss. Suppose a room is needed air conditioning. This outlet, what we are releasing the air, it has to send out through drills or registers. You know what is drills, register? So in next class we will discuss. Openings, suppose it is centralized air conditioning room. We will discuss about the types of air conditioning also next class, centralized air conditioning, and the window air conditioning and the unitary air conditioning also. Conditioning we can discuss later. And if it is a centralized air conditioning, you can't find any evaporators and condensers maybe nearer to the building. Maybe the total plant is located somewhere outside, and from that through ducts we can get the cooling where we are getting the air. The drills and registers like, right? And the air is coming one way, and the air also go out, right? And this air maybe we can recirculate also. Every time maybe we can't take fresh air, we can take, because some temperature is low compared to outside temperature, right? So that we can recirculate the air. The recirculation process is maybe some amount of air we can take. That will be in that case you have to find out, you have to calculate the bypass factor, right? And suppose hospitals maybe some blood storage or maybe units can't recirculate the air again. Right? Maybe the disease is maybe very dangerous. If you can replace again the air, maybe it is affected other people. That's why for that case air we can't recirculate. It is outside. We will discuss later how it is. That is the bypass factor. Next. Okay. Thank you.